Good afternoon, everyone. Can everyone hear me? Awesome. Yes, for your question, this session will be recorded and I will upload it to YouTube directly after this class. So I figured we can start off with the mock test. Did everyone attempt the mock test? So this is just a recap session. So I'm here for question and answers, and I would like the session to be as interactive as possible. Otherwise, there's no point in it. So that everyone here at least attempt the mock test. Okay, would you want me to go over the mock test with you? Awesome. So the questions in a mock test and the way the mock test is set is exactly the same way the test on Monday is going to look like and be. And it's also going to be on the same difficulty level. So remember, the test is not difficult. I'm not here to test your how good you are at regurgitating facts. I'm interested in to see, do you understand the work? So the first, uh, before I start with this, would you like some more details on the semester test? Okay, so for the semester test, it's going to be an hour and a half, and it's worth 50 marks. So from that 50 marks, it'll be divided into two sections. The section A is multiple choice, and section B will be longer questions. So for the multiple choice questions, you will have 30 questions. Each question is worth 1 mark. So 30 multiple choice questions, 30 marks. And then the rest, the other 20 marks, is a bit longer questions that you need to answer in a sentence or two. Yes, you must bring a calculator. So look at the calculation questions we did, the reasoning with numbers question in the textbook. You will need calculators for that. So let's go through the mock test. So question A, the average distance from Venus to the Sun is what? What would you guys say? The average distance from Venus to the Sun is 1.2 light years, 0.72 AU, 1.3 million kilometers, 1 billion kilometers, or 2.3 million miles. Yes, number B is correct. Why is number B correct? Because if you go through this, 1.2 light years is too far away. Remember, the closest star to us, besides our own sun, is Alpha Centauri, which is 4.2 light years away. So that means we're already a quarter way to our nearest star. So no. Remember, Earth's orbit is 150 million kilometers. So Venus' orbit lies below Earth's orbit. So 0.72 AU, yes, that sounds about right. 1.3 million kilometers, that's way too short because remember 150 million is 1 AU. 1 billion kilometers, that's too long. So 1 billion kilometers is, remember, Saturn's orbit is about 9 AUs. So that's way too long. And 2.3 million miles is way too short. So the answer is B. So you guys understand how you can figure out which is the correct question. It's not difficult, right? Awesome. So question number 2. Our Milky Way galaxy has a diameter of 75,000 light years. How long does it take light to cross the diameter of the galaxy? Is it A, 75 years, B, 150 years, C, 30,000 years, D, 75,000 years, or E, 150,000 years? So remember, a light year is a measure of distance. So, and it's also how long light travels in 1 year. So if the diameter is 75,000 light years, it will take D, like 75,000 years to cross the galaxy. You guys happy how I got to this answer? Awesome. No, who said no? So remember, it take light. If something is 1 light year away, that's the distance light travels in 1 year. So that means if something is 1 light year away, so light will reach it in 1 year. If it's 2 light years away, light will reach it in 2 years. So now the diameter of our galaxy is 75,000 light years. So light will travel across the diameter, which is 75,000 light years, in 75,000 years. Does that make sense? Awesome. So question number 3. If light takes 8 minutes to reach Earth from the Sun and 1.3 hours to reach Saturn, what is the distance from Sun to Saturn? 1.3 AUs, 104 AUs, 9.75 AUs, 1.3 light years, or 0.16 light years? So yes, C is correct. Do one of you want to volunteer to show how you've done it, or should I show you how to do the calculation? Yes, that is correct. So one way you can do it is you can say, write it as 8 minutes equals 1 AU. At AU, you can write as 150 million kilometers. So how many minutes is 1.3 hours? Yes, 78. So now you can say 78 equals x. So what do you do to solve for x? Yes, you cross multiply, right? So now you can say 78x, sorry, not 78x, sorry, it is 8x equals 78. So x equals 78, divide 8, and that gives us roughly 9.75 AUs. You happy how we calculated this? So yes, I see it's not difficult calculations. You just need to apply yourself. So now, question number 4. The apparent visual magnitude of a star is 7.3. This tells us that a star is A, one of the brightest stars in the night sky, B, bright enough that it would be visible during the day, C, not visible with the unaided eye, D, very far from Earth, or E, very close to Earth. So remember, it's the keyword apparent visual magnitude. So which one of these would you say is the correct answer? C, the correct answer is C. You guys are correct. So when you say it's 7.3, if you say it's one of the brightest stars in the sky, that is not true. The brightest star is Sirius. And I think that's sitting at I think a 0 or 0 point something magnitude. So that's not true. Bright enough that it would be visible even during the day. No, that's not true. Very far from Earth, you can't tell how far it is away from the apparent visual magnitude. Very close to Earth, you can't tell that with the apparent visual magnitude. So yes, not visible with the unaided eye because the human eye can only see up to magnitude 6. So question number 5. An object has been located orbiting the Sun at a distance from the Sun of 65 AU. What is the approximate orbital period of this object? A, 65 years, B, 275,000 years, C, 4,225 years, D, 8.1 years, or E, 524 years. Which would you say is the correct answer? One say C, one say E. So the hint is here in your formula sheet. You are going to use this formula. MA plus MB equals A to the power 3 rho squared. So remember, we are working with objects in our solar system. So we can basically say this is simplifies to 1 solar mass equals to A to the power 3 over rho squared. So this can simplifies to 1 equals A to the 3 over rho squared. And that can now simplify to this form over here. Okay, so where do we plug our 65 AU in? So let's plug it in there. So now you can say squared equals 65 to the power 3. So now if we solve for rho, what do we get? Yes. So now when we solve this, we can rewrite this as 65 3. So the mass of the object is not 0, it's 1. and that gives us 524. So remember, the key here is, are we allowed to use calculators in exam? Yes, you must use calculators in exam. Yes, please. So one thing is, yeah, we are working with a distance from our own. So this object is 65 AUs from the sun. So remember, 99% of the mass in our solar system is inside the sun. So that means these, we can say this is the sun, this is the object. So because 99% of the mass is in the sun, we can basically say those two masses combine to one solar mass. So that's why we can say this is one and do the calculation. Does that make sense? Yes, you will get your formulas. So you'll see in the mock test, there is a formula sheet on the second page. And those are all the formulas that you'll be able or need to use. Everybody happy with this? I can't see your calculation. Can everyone see? Can anyone, someone else see my calculation? So this will be available as a recording afterwards. So now the next question. So with question 6, the SAR alpha CMA has an apparent visual magnitude of minus 1.6. So the key here is apparent visual magnitude of 1.6 and star alpha CET has an apparent visual magnitude of 2.53. So remember, this is the one key term, that is the other key term. So both stars are the same distance from Earth. This tells us what? That alpha CMA will appear fainter than us than alpha set. Alpha CMA must produce more energy than alpha set. Alpha CMA must produce less energy than alpha set. Alpha CMA must be further from alpha set. And alpha CMA must be close to alpha set. So the correct answer, yes, you are correct. That is answer number B. So remember, uh, both stars are the same distance from Earth. So because they are the same distance from Earth, we can already rule this one out. We can rule this one out. So because they are the same distance, things that we can say is, yes, alpha CMA will appear fainter. No, because it has a higher apparent magnitude. So this one is not correct. So the only thing we have is the one will produce more energy than the other one, and the brighter one will produce more energy than the other one. So that is why answer B is the correct one. You happy with how we got this answer? Awesome. So question 7, the table below lists the spectral type of 5 stars. Which one has the greatest surface temperature? So question, so how does the order of magnitude work? So the order of magnitude that we went through, I think it was one of the first two lectures is the if you look from 0 to 6, so the higher the number is, the more fainter it is. So it is a logarithmic scale. So at magnitude 6, that is the limit of the human eye. But if you go into negative numbers, then the object becomes even brighter. And that's how it works. So pleasure. So the table below lists the spectral types of 5 stars. Which one has the greatest surface temperature? So remember our little rhyme. O, B, A, fine, guy or girl, kiss me. So which one will have the greatest surface temperature? That is correct, number E. So it means O will be the greatest surface temperature, M the coolest. And then within these, you have your own, let's take M for example. You have M0 all the way up to M9, where M0 is hotter than an M2, for example, and M2 is hotter than an M3. You're all 9, where M0 is hotter than an M2, for example, and M2 is hotter than an M3. You're all happy with how we got this answer? Awesome. So question number 8. Most of the light we see coming from the sun originates in the what of the sun? So the chromosphere, photosphere, corona, sunspots, or magnetic field. So I see a C, I see a A, I see another C. So which one would you say is correct? I see a B. So the correct answer is B. Most of the light we see coming from the sun originates in the photosphere. So remember our lecture that we did on the sun. Then question 9, a hint, because there's so few people in class, I can give this hint. So for this, so this is a type of question that I like to ask, if you catch my drift. So star A has an apparent visual magnitude of 15.4, and star B has an apparent visual magnitude of 12.4. This means star A is what then star B? So the hint I can give you here is FA over FB equals 2.51 to the power MB minus MA. Right. So where do we plug in what in this equation? So I see, yes, the correct answer is C. You guys are correct. So what you will do is star A, we plug it in here. Star B, we plug it in here. And then we do the calculation, and then we'll see star A is 16 times fainter than star B. You happy with this? Awesome. So you all, why is it fainter? So remember, we're working with apparent visual magnitudes. So remember, 15 is bigger than 12. So remember, the smaller the number, the brighter it is. So that means there's a bigger number than 12. So star A is fainter than star B. Does that answer your question? Awesome. So just a hint, I like to answer this, ask this type of question. It is 2.51 to the power MB minus MA. Pleasure. So question number 10. The what is or are the hot gases that are the moving extension of the sun's coronae. So, is it A, specules, B, prominences, C, flares, D, supergranules, or E, solar wind? The smaller the number, the brighter the star. The bigger the number, the fainter the star. So what would you say is the correct answer for question number 10? Yes, you are correct. Solar wind is the hot gases that are the moving extension of the sun's corona. Now, question number 11. When we say that gravitation is universal, we mean what? So would you do a question where you give the apparent visual magnitude, another in absolute? No, I won't do. So when we say that gravitation is universal, we mean what? And that is A, it is important in all aspects of science. B, it could be deduced from the apparent appearance of the universe. C, for every force there is an equal and opposite force. D, the force of gravity from one object extends to infinity. Or E, it is a property of all matter. Which would you say is the correct answer? Yes, you are correct. The correct answer here is E. It is a property of all matter. Question number 12. Also be D. The force of gravity from an object extends to infinity. No, you can't really see. I understand what you're saying, but yeah, I'm specifically looking, it's a property. Even in scripture, I understand where you're coming from, but yeah, I'm looking for it's a property of all matter in this case. But I understand where you are coming from. So question number 12. To determine the radius of a distant star, we need to know its what? Temperature or distance. B, chemical composition, luminosity. C, spectral type and absolute magnitude. D, temperature and luminosity. Or E, distance and mass. So the correct answer here, to determine a distant star radius, we need its temperature and its distance. All happy with this answer? Okay, so could you please explain it? Okay, so here is the keyword we want its radius. So if we want its radius, we need to know a few things about the star already. So the one thing is we need to know is its temperature. So the chemical composition luminosity will tell us nothing about the radius. The spectral type and absolute magnitude will also tell us nothing about the radius. The temperature and luminosity won't tell us anything about its radius. The distance and mass won't tell us anything about its radius. But if we know the temperature and if we know the distance, then we have enough information to calculate the radius. Does that make sense? So no need to plug it into a formula. We have done that in our lecture about the stars. We look at the family of stars. It was in that lecture where we covered this principle. So question 13. The force of gravity between two objects depends on what? A, on the mass of each object. B, on the distance each object is from Earth. C, the distance between two objects. Number D, A or C, or E, all of the above. So the correct answer is number D. I'm looking for A and C. It depends, so the force of gravity between two objects depends on A, the mass of each object, as well the distance between these objects. Happier now we got the answer? Awesome. So question 14, on the HR diagram, white dwarfs are found where? In the upper right corner, lower right corner, upper left corner, lower left corner, on or on not on the HR diagram. So the correct answer is number D. White dwarfs is in a lower left corner below the main sequence. So question 15. Absorption lines due to the interstellar medium indicate that some components of the interstellar medium are cold and of low density gas because the lines are blue shifted. That tells us nothing about it. The lines are red shifted. That tells us nothing. The lines are extremely broad. That could be. The lines are extremely narrow. That could be. The lines are much darker than a stellar line. So that doesn't tell us anything. So now we know. Let's go through the question again. Absorption lines due to the interstellar medium, that's the one key word, indicate that some components of the interstellar medium are cold and of low density gas. So when we look back at our lecture, when we see cold, low density gas, the only option we have are number D. The lines are extremely narrow. You guys happy with this explanation? So when you look at our lecture that we discovered different spectra, remember we have absorption spectra, emission spectra, and continuous spectra. So something happens to the line, specifically when a medium is cold and it's a low density gas. So if it's cold, if we're speaking specifically about absorption lines, if the components is cold and it's a low density gas, then the lines are extremely narrow. If it was hot, then it would be extremely broad. Does that answer your question? Awesome. So any question regarding wavelength, well, we need to know the average wavelength for a specific color or electromagnetic spectrum. So now I won't ask you for the semester test, I won't ask you anything about the wavelength. But if I'm going to ask something about it, let's say, for example, the exam, I will give you all the information that's needed for that specific question. Pleasure. So question number 16. The Copernican system was not accurate in predicting the positions of the planets because A. It used the old value for the radius of Earth. B. Copernicus had been unable to detect parallax. C. It included uniform circular motion. D. Only Mercury and Venus orbit the Sun. All the other planets orbit Earth. Or E. Copernicus used its inaccurate data from Ptolemy. So let's go through it. So it's used the old value for radius of Earth? No. Copernicus has been able to detect parallax, no. Included circular motion, can be. Only Mercury, Venus orbit the Sun, the other planets orbit Earth, no. Copernicus used an apparatus from Ptolemy, no. So when we look at our intro lecture, it included uniform circular motion, so C. So question number 17. Galileo's telescopic discoveries of the moons of Jupiter proved what? That A, Jupiter orbits Earth, B, Jupiter orbits the Sun, C, the Earth can move without leaving its moon behind just like Jupiter, D, Jupiter's orbit was a perfect circle, and E, Jupiter has phases. So the correct answer I'm looking for in this question is C. The Earth can move without leaving its moon behind, just like Jupiter. Because Jupiter also has moons orbiting around it. You guys happy with this answer? So can you explain how this discovery is important? It is important because when Galileo looked at Jupiter, he realized that Jupiter has moons orbiting around it, which proved that not everything in the universe orbited around Earth. So when we went back to the old model, then the moons of Jupiter would orbit around Earth as well, which is wrong. It's the first time that we can see another heavenly body with natural occurring satellites orbiting it. So we had now moons orbiting Jupiter. Does that answer your question? So yes, that builds up to that while the moons are orbiting around Jupiter, Jupiter is orbiting around the Sun. And that is why it is important. Awesome. Question 18. A solar or lunar eclipse will occur A, when the sun is near the line of nodes of the moon and the moon is new or full. B, anytime the moon is new or full. C, when the sun is near the solstice and the moon is new or full. D, halfway through the eclipse year. E, when the sun is near the equinox and the moon is new or full. The correct answer I'm looking for here is A, is when the sun is near the line of nodes of the moon and the moon is new or full. So what that means is when we have the sun, here we have the moon, here we have Earth, and these are the nodes it's orbiting with. So now we can get a solar eclipse, or when the moon is on this side, and let's get another color out. This is the Earth's shadow, and the moon is in this shadow, and it has to be new or full. Does that answer the question? The line of nodes means if we look at the system, so here we have the sun. Let's use different colors. Here we have Earth. Why did that move all of a sudden? Let's redraw it. So here we have the sun, we have Earth, and we have the moon, for example. So what the nodes mean is, that means we have a node over here. When everything is in a straight line, we have a node over here when everything is in a straight line. So when everything lines up in a straight line, we have a node over here and a node over here. What happens? Do we have a solar eclipse or a lunar eclipse? and that always coincides with a full moon or a new moon. Does that answer the question? Awesome. So, question 19. The ecliptic is what? It's A, the center line of the zodiac, B, the projection of Earth's orbit in the sky, C, the apparent path of the sun around the sky, D, all of the above, or E, none of the above. So yes, you are correct. The correct answer is D, because the zodiac is the center line, the zodiac ecliptic. The projection of Earth's orbit on the sky is in the ecliptic, and the apparent path of the sun around the sky is also in the ecliptic. Does that answer the question? Everyone happy? Awesome. So question 20, this is something I discussed in class, is star names are what? C, you are correct, Arabic. So, contrary to popular belief, most star names are Arabic. You guys happy with this? Awesome. So now we can go on. So are we to expect a question of two things you said in class? Now I can't remember, but majority of things will be in the textbook. Awesome. So question 37. Come on. Why did it jump from 20 to 37? That's a mistake, but just named it incorrectly. But why is convection important in a star and it's worth 2 marks? Will the lecture slides be okay for study if you don't have a textbook? Yes, that will be more than fine. So, yes, that'll be more than fine. Yes, that will be fine. So for this question, why is convection important in a star? So it helps transfer energy from the hot core to the outer layers. Yes, you are completely correct. So here I'm looking for energy transport and energy transfer. So it transports, or better word is transfers energy from the hot core to the outer cooler layers. You guys happy with that answer? Awesome. So question 34. Describe 4 of Galileo's most important telescopic discoveries. So I've hammered on this in class. What are some of his 4 most important discoveries? Yes, the moons of Jupiter is one of them. Phases of Venus, yes. Sunspots, yes. So not Earth is not a center, not looking for that one. So what I'm looking for is Jupiter has moons, Venus has phases, the sun has sunspots. Four, the moon has valleys and craters. So yes, the surface of the moon. Those are some of the four ones. There's two others in the textbook as well. But so there's I think six you can list, but these are the four easiest ones. So sunspots, phases of Venus, Jupiter's moons, surface of the moon. You happy with that? Must we explain them or only list them? So I will usually tell them, but look at usually your mark allocation. If it's 4 marks for significant discoveries, that's just list them. So for example, this was 8 marks, then it will be 1 mark to list them and 1 mark to describe them. Does that answer your question? Awesome. Then 21. How does a gas cloud become hot enough to ignite nuclear reactions? So we've done this literally a week ago. So yes, you two are correct. So the correct term I'm looking for is through gravitational collapse. So if you ask what a triggering event was, the triggering event was a shock wave, and then the rest is gravitational collapse. You guys happy with this? So I'm just looking for one more thing. Where would this be? Not helping. So just give me 1 second. So question, sir, how many longer questions will there be in the test? I will tell you now. So it's 30 multiple choice questions and the rest questions, so there will be 9 longer questions. So 39 questions in total, where 30 of them will be multiple choice. Copy. So can you please go through question 9 again? I will do so momentarily. So I'm just going to stop the recording for 1 moment.